It is just a 10-feet flight by a feeble-looking drone, but NASA's ingenuity has taken a giant leap in solar aviation as NASA's team dare mighty things. It was say cheese moment when NASA's rover Perseverance took selfie with humanity's first Mars helicopter Ingenuity. In elation, project manager at Jet Propulsion Laboratory, Miami Ong, tore away the papers in her hands. The paper was a contingency speech which she wrote in case the mission develops some snag or mission fails. But NASA is never afraid of failures. They dare mighty things. After a successful Ingenuity flight, NASA is determined to go ahead with next scientific experiment of converting Martian carbon dioxide into oxygen, and that will pave way for future Mars astronauts. Chief engineer of Mars Ingenuity helicopter is Indian origin IIT Madras alumnus Bob Balaram.
We have Dr. Mohan here with me. Of course, you know her from the landing coverage.
Hey Doc, how are you?
I'm doing very well, Mr. President. Perseverance is my first mission at JPL where I've gotten to work from the very beginning of formulation all the way through operations. Being able to work with this incredibly diverse, talented team that has become like a family, spending years creating our own technological marvel has been a privilege.
Well, I tell you what, you've created a dream for millions and millions of young kids.
Flight of a powered, controlled helicopter on Mars 278.4 million kilometers away from Mother Earth, having low gravity and very thin, just 1/3 of the atmosphere, with merely 1% of the pressure at surface in comparison to our living planet, was a challenge. This means there was relatively few air molecules with which Ingenuity's two 4-foot wide rotor blades can interact to achieve flight. Temperature at night dips as low as 139 degrees Fahrenheit or 59 degrees Celsius.
As a terminology, whether you call it a rotorcraft or a helicopter or a drone, you could use those interchangeably. I think one of the connotations of drone here is that it's has a little bit of an off-the-shelf. You go buy it at your favorite store, and you can fly it out of the box. Ingenuity is quite different. It had to be designed from the ground up for a very alien, very harsh environment. We don't have drones that, survive minus 130 degrees Fahrenheit at night. We don't have drones that fly in 1% of the atmosphere of Earth.
The solar-powered Mars helicopter first became airborne at 4 minutes past 1 p.m. Indian Standard Time or 12:33 local Martian solar time or Mars time. A time the Martian team determined would have optimal energy and flight conditions. Altimeter data indicated Ingenuity climbed to its prescribed maximum altitude of 10 feet and maintained a stable hover for 30 seconds. It then descended, touching back down on surface of Mars after logging a total of 39.1 seconds of flight. Ingenuity's initial flight demonstration was autonomous, piloted by onboard guidance, navigation, and control systems running algorithm developed by the team at JPL.
Ingenuity itself is extremely healthy at this point. In fact, she's even healthier than she was before this flight. She shook off some of her dust that had been covering her solar panel and is in fact producing even more solar energy than before. The batteries are looking good. The communication system is fantastic. The landing gear appears to have worked well. All the servo mechanisms and motors are doing great. The computers and the avionics behaved flawlessly. So all in all, it's in a perfect state, and I'm just really excited to see what all she can teach us over the next few weeks as we explore aerial mobility on Mars.
Because data must be sent to and returned from the red planet over hundreds of millions of miles using orbiting satellites and NASA's deep space network, Ingenuity cannot be flown with a joystick, and its flight was not observable from Earth in real time. The Mars Ingenuity's flight was iconic to Wright brothers, who made first flight on Earth 117 years ago. Ingenuity's chief pilot, Howard Grip, announced that the International Civil Aviation Organization, ICAO, the United Nations Civil Aviation Agency, presented NASA and the Federal Aviation Administration with official ICAO designation IG by call sign Ingenuity.
And the location of the flight was assign an ICAO location designator, JZRO, for Jezero Crater, where the NASA Mars operation took place.
The 19.3-inch tall Ingenuity Mars helicopter contains no scientific instruments inside its tissue box-sized fuselage. Instead, the 4-pound rotorcraft is intended to demonstrate why the future exploration of Red Planet could include an aerial perspective. The helicopter contains unique components as well as off-the-shelf commercial parts, many from the smartphone industry, that were tested in deep space for the first time with this mission.
The fundamental, dynamics of these vehicles does scale up to fairly reasonable sizes. So we are thinking of things in the 25 to 30 kilogram class, which is, about the 50 pounds type of class of vehicles. And those vehicles would carry maybe about 4 kilograms of science of that order, about 10 pounds of science instruments. And so early design work on that has started in terms of conceptual designs, and to see what would it take to deploy these and operate them. And so that would be, I think, a good sweet spot for the next generation design. Anything much larger, the packaging of the blades and things becomes quite awkward, so may not be quite feasible in the near term. But definitely something in the 50-pound class compared to a little 4-pound Ingenuity is definitely something that's very feasible, and is actually like some early progress has been made in that direction.
7, 6, 5, 4, engine ignition, 2, 1, 0. Right, and liftoff. As the countdown to Mars continues, the perseverance of humanity launching the next generation of robotic explorers to the Red Planet.
Parked about 211 feet away at Vangeal Overlook during Ingenuity's historic first flight, the Perseverance rover not only acted as a communications relay between the helicopter and Earth, but also chronicled the flight operations with its cameras. The pictures from the rover's Mastcam Z and Navcam images will provide additional data on the helicopter's flight. Perseverance touched down with Ingenuity attached to its belly on February 18th. Deployed to the surface of Jezero Crater on April 3rd, Ingenuity is currently on the 16 Sol or Martian day of its 30 Sol flight's test window. 1 Sol or Martian day is equal to 1 day, 0 hour and 37 minutes of 1 day on Earth. Over the next 3 Sols, the helicopter team will receive and analyze all data and imagery from the test and formulate a plan for the second experimental test flight, scheduled for no earlier than April 22nd. If the helicopter survives the second flight test, the Ingenuity team will consider how best to expand the flight profile. To say the least, Ingenuity's successful flight preceded by an issue fix and a spin test was done. Now NASA is heading to test a new device named as MOXIE on Mars rover Perseverance. J. Bob Balaram, Chief Engineer of NASA's Ingenuity helicopter, is principal member of technical staff at the NASA's Jet Propulsion Laboratory, where he is with the Mobility and Robotics Systems section. He received his PhD in Computer and Systems Engineering from Rensselaer Polytechnic Institute. JPL website describes that at JPL, he has been active in the area of telerobotics technology developed for Mars rovers, planetary balloons, aerobot systems, and multi-mission high-fidelity spacecraft simulators for entry, descent, and landing and surface mobility. PhD Computer and System Engineering, Rensselaer Polytechnic Institute in 1985, MS Computer and Systems Engineering, Rensselaer Polytechnic Institute 1982. He did his BTech Mechanical Engineering from Indian Institute of Technology, Madras in 1980. There is no limit to achieve new goals. Mars Ingenuity proves once again, and MOXIE will pave way for future human colonies on Mars.
The general technique of aerial flight is applicable to, places like Titan and Venus. The specific vehicle, I think, will be quite different. Titan's a much easier place to fly, easier even than Earth in some regards. And Venus, depending on where you want to fly, has, certain temperature issues. So the specific designs will be, quite different. But yes, this does open up that doorway. And I think the bigger lesson here, I think, is also how do we operate these vehicles? How do we test these vehicles? So there is that kind of knowledge that we have learned from this process of flying Ingenuity that will definitely transfer over and be useful for the folks who will be considering missions to those places.
Humanity is proud of NASA and everyone working at their laboratories. If you like the video, consider sharing and subscribing my channel by hitting red button and pressing bell icon. Thanks for watching. Jai Hind, Vande Mataram.